Today we're going to be talking about Taylor and Maclaurin series, and I've kind of been referencing these all along, and I actually gave you guys on a different screen some Taylor and Maclaurin series that I want you guys to remember, but I'm going to talk a little bit more about these right now. So, okay, Common Power series. Remember our book calls these, um, I was looking at this last night before I was preparing, and I prefer to call these Maclaurin series. Because they're technically Taylor series centered at zero. Our book calls them the elementary series. Okay, so sine of x. And I'm going to be giving you guys some memory techniques that I use to memorize these. Some of them I have really good memory techniques for, some of them I don't. Remember in the activity we did, sine of x, we started with our y equals x. Okay, and we kept going back and forth and looking at odd exponents of graphs. Okay, and remember when I'm looking at the graph of sine of x, the graph of sine of x is an odd function. It's symmetric about the origin. So that's how I remember sine of x is always odd numbers. Versus cosine of x, okay, you just take the derivative of sine of x, so cosine of x is an even function, and even just looking at the graph of cosine of x, cosine of x is an even function, symmetric about the y-axis, okay? E to the x, I have a silly way of remembering this, and it's so silly, I thought of it the first year, okay? I remember it that I was teaching this class. And I remember it as everybody in. Exclamation point. The exclamation point's important. Everybody in. You start with 1 and you have every power with the exponent, the factorial on the bottom, not exponent, the factorial, the exclamation point. So that's how I remembered those three. The other ones, I don't have the best way to memorize these. This first one, remember, is just a geometric series. We've kind of already talked about that. So the geometric series where your a is 1, your ratio is x, so you just keep multiplying by x. In this one, it's a geometric series, just your ratio is negative x. Okay, there's a few more that I want you guys to remember. Remember arctan. We did this in the 8.9 video. We substituted in x squared and took the integral. Okay, arctangent, I don't know. I don't have a good way to remember this one. It's all the odd numbers. I look odd when I tan. I don't know. And I'm not excited about my tan, so that's why there's no exclamation points. I don't know. I just came up with that. And then you have 1 over x, where basically you're substituting in here 1 minus x. Okay. And then ln of x is just the antiderivative of 1 over x. Okay, so make sure you have those written out. Make sure you have those memorized. These are ones that it's one of those quick things, kind of like derivatives, that you want to know to be prepared for the AP test. Okay, so let's do some examples. What I want you to be able to do with these. Okay, find a Maclaurin series for g of x equals cosine of x squared. Okay, so what I want you to do here is we remember that the cosine of x, remember cosine of x is an even function, so I start with even exponents. And make sure you're paying attention to what they want for the number of terms. I'm going to give you the general term. And we've kind of already talked about this. What you do is you replace your x with an x squared. So I now have the cosine of x is approximately Notice how it's not equals x. Typically, it's either 3 or 4 terms that they ask you for in the AP. So notice how the only thing that I didn't do, that factorial should be outside the parentheses. That's two very different things than I have written there. Is now I want to make the x an x squared. So all you do is substitute in an x squared. And again, you don't have to worry about simplifying these. That's all you have to do. Okay, so now for the next one. So for the next one, I was looking at my notes. Okay, the ln of x, I don't know. You guys need to give me a good way to remember the ln of x one. I struggle with remembering this ln of x one. I don't know why I do. And I challenge my students every year a good way for me to remember it. And nobody ever gives me a good answer. So now what I'm going to be doing is I'm just going to be substituting in an x minus a 2. So let's look at what that looks like. So x minus 2, if I substitute an x minus 2 in for x, so that's going to get me, I'm sorry, an x plus 2. That's going to get me x plus 1. And so that just changes everything, the x pieces that we have here. And let's look at that. Okay, x plus 2, so I'm basically shifting from ln of x to x plus 2. I'm shifting everything over to the left 2 inches. So I'm shifting my center, which was at 1, over 2 inches, over 2 units. Okay, so that's all you're doing there. Okay, so this is all that you're doing. Okay, is making a new series off of our known series. And it really helps you if you memorize those Maclaurin series that I have for us. Sometimes on the AP test, they're going to ask you to multiply series out. Okay, so you have to remember a couple of series. We have to remember our e to the x series. And since it says first 3 non-zero terms, okay, that's going to be key to us. E to the x, remember, everybody's in. We're excited about everybody's in. Understanding that I go on forever. I don't like that I have an equal sign there because this is an approximation. Sine of x is equal to x. It rotates. We have all of our odd exponents. I don't think I'm going to need more than x to the 7th here. Again, I keep putting that equal sign. I don't like that. This is an approximation. Okay, so I'm going to multiply these two together. So basically, I'm going to multiply this times by this. And remember, you want the first three terms. So I'm going to take the 1 and I'm going to multiply it to all of those. So my first set of terms is this. And then eventually I'm going to have to combine like terms. Some of these terms I might not end up using. I'm going to take away this parenthesis. Now I'm going to take this term and multiply it times everybody. I'm using colors just to help organize myself. Okay, so just looking at this right now, I notice I have an x term and an x squared term. So I know that my final answer is going to have an x plus an x squared. I know I have an x to the third here, but I'm going to keep going through and multiplying, because when I take and I multiply this term times by everyone here, I'm going to have some x to the thirds and some additional terms I'm going to need to combine. So I'm going to take it, I'm going to multiply that by I'm not going to worry about multiplying those out because I don't want to mess anything up, but I am adding the exponents. I don't think I'm going to do any more because I don't think I'm going to need any more. So I've combined this x and this x squared. It doesn't appear that I'm going to have any more things to combine with those. So now I'm going to combine anything that is an x to the third, because I need three terms. So I have a plus quantity x to the third. I have a 1 over a 2 factorial minus a 1 over a 3 factorial. Now let's combine any term that we would have that would be an x to the fourth. Okay, I have an x to the fourth here, but if I take and I multiply this x to the third times by this first quantity there, I'm going to get an x to the third, I'm sorry, an x to the fourth over a 3 factorial. So I have another x to the fourth term I'm going to need to combine. So I combine this x to the fourth term with this x to the fourth term. Oh, that's kind of fun. They actually cancel each other out. Ooh, did I multiply correctly? I did. I don't think I multiplied correctly last night when I did it. Okay, so now I need to go to my x to the fifth terms. So my x to the fifth term, and I made up this problem, so I don't know where my correct answer is. Well, I'm sure I could find it somewhere. So my x to the fifth term, I have one here, I have one here, but my x to the fifth term, if I take this x to the fourth and I'd multiply it by that x, this x to the fourth, multiplying it by that x, I would have an x to the fifth over 4 factorial. So I actually have 3 of those I need to combine. So when I combine all of those, I factor out the x to the fifth, And I would have a 1 over a 5 factorial minus a 1 over a 2 times a 3 factorial plus a 1 over a 3 factorial. So hopefully I did that right. I paused it real quick and just double checked my math on my x to the fourths. I didn't think they would cancel, but it looks like they did. I must have messed something up last night when I was doing this. Okay, so that's how you would multiply. Okay, it's basically just multiplying, really. I made it a really hard example, but it's basically just multiplying. Okay, so now we have this example. I want us to keep in mind that we can use this property. Okay, so remember that our ln of, I think we just did, no we did ln of x is x minus 1 realized I made a mistake. These rotate. Oh, eraser. I am giving up. I've been spending a few days recording videos in preparation for semester 2 of our 2021 school year. And I think I've exhausted myself in recording of my videos. So remember that this is an approximation. So I take and I add in an x plus a 1, which basically just turns this into, x minus x squared over 2 plus an x cubed over 3 minus an x to the 4 over 4 plus those dots mean we keep going. Those are important. And then we want to multiply this by a 2. So you just multiply all the terms by a 2. Okay? And if they ask for the general term, we have to write negative 1 to the n minus 1 x to the n all over 2n. So that would have come from finding this general term here. And then you would multiply everything by 2. I wonder why there's no... Oh, they don't give it to me. Okay. I was wondering why there was a 2n on the bottom. I think it probably has to do with some stuff that ends up canceling. Okay, that is our video for Taylor and Maclaurin.